Power for the media hub, ground straps. We're talking about it right now.
Welcome to the channel. This is Technoscope.
So the first thing I want to talk about is the Collective Minds Media Hub for the Xbox One, the expansion bay that adds a hard drive, external hard drive for additional storage, and also adds 3 USB 3.0 ports to the front of the Xbox One. Some of you have asked, how can you add power to this device? Now, let's get this correct. If you're just going to use the device to run the hard drive, or if you're just hooking up things like a flash drive or something like that, you don't need an additional power source. The only reason you need an additional power source is if you're going to actually be using the hard drive and also charging game controllers with the media hub. So in that case, you need a little additional power other than what the Xbox can provide on the USB 3.0 port. And to do that, there are a couple of methods. Now, the way I chose to go about it was to use this proprietary cable. It can be bought from Amazon, and I will have the link in the description below. This cable right here has the 5.5 millimeter jack on one end and the USB connection on the other end. Remember that the media hub uses 5 volts. It requires 5 volts. Now, a lot of you may have these sitting around your house. I've had several Samsung Galaxy phones. This one came from the Samsung Galaxy Note 3. It provides 5 volts, or actually 5.3 volts at 2 amps, which is more than enough to give the media hub a little more juice. Now, I would stay away from some of the turbocharging power supplies, even though they shouldn't crank up the juice unless they're connected to a device that actually specifies, communicates with it, saying that it can support it. But even so, I would stay away from them. Some of them can provide upwards of 9 to 12 volts, and that kind of voltage can actually damage your device as well as your Xbox One. But this particular one that came with the Note 3 provides 5.3 volts, which is well within safety specs and would work just fine for it. 2 amps, this is a good supply. This cable is not very much. Like I said, I have the link in the description below. But if you don't want to go this route, if you don't have one of these, do not go buy one of these to do this. This is affordable because I already had one. If you had to go buy this little guy, this thing would cost you about $30 from Samsung. Now there are cheaper 2.0 power supplies out there, but even all the same, I wouldn't go buy one for this. Instead of doing that, I would use a 5 volt dedicated power supply, and I'll link to one of those down in the description below as well. Now, moving on from that, the other thing I want to talk about was ESD. Now, in my last video about building the computer for my son, we talked a little about ESD and some of the problems that it can cause. Now, the way that semiconductors work is they are transistors that have a insulating barrier in them. They will have voltage applied to one side. This barrier is set up that will not allow electricity to flow without voltage being applied. And then once voltage is applied, the electricity is conducted to the other side of the transistor. Now, if you touch a semiconductor with static buildup and you shock that device, you can actually break down that barrier that keeps a transistor from conducting. And basically what you can do is blow the barrier wide open, meaning that when the transistor comes in contact with the voltage of the system, it's like having a dead short. And if you've ever seen shorts, basically you end up with smoke, fires, things popping, and basically you have a dead device. So that is why ESD protection is very important. You do not want to break down those barriers even a little. Just a little damage to it can cause it to be a lot more inefficient. Doing a lot of damage to it can completely ruin it. So the main thing that you want to have when you're working on computers, semiconductor devices, is a wrist strap. This one right here, basically you take it, put it on your wrist. I'm not going to go through all that, but close it up. And basically it makes contact with your skin using the metal part underneath. And this part here, which is a wire, will clamp to the chassis of the case. Now, in my last video I said that if you're going to do that method, or even if you're not using this, the best thing to do is to plug in the power supply of the case and leave the switch turned off. And that way the entire case is still grounded even when there's no power being applied to it, because the power supply is grounded and the power supply is physically connected to the case, which grounds the whole system through the power cord, through your electrical system, assuming that the wiring in your house or wherever you're plugging it in is wired properly. Now, the alternative to having that set up is to use a grounding system. Now, this procedure that I'm going to show you is an alternative. Say you're building a computer and you don't have the power supply, but you're going to go ahead and put in the motherboard and everything. This is an alternative to that. Now, keep in mind that this do-it-yourself kit setup that I'm going to show you can be very dangerous. Electrocution, let's go ahead and break this down. Electrocution happens when high voltage, high enough to travel through your body, travels from one side or through vital organs in your body and shuts them down, whether it be your heart, your brain, or whatever it may be. So the worst thing you could ever do is to have voltage going across, especially the midsection of your body. You touch something this side and it's coming out this side, it could kill you if the voltage is high enough and there's enough current flowing. Now, if something, say like you get it across your hand or something, it could hurt a lot, it could burn you, it could do some serious damage, but it's a lot less likely to actually kill you because it's not flowing through your body. That's the crucial thing. You don't want it flowing through your body. Now, when you're using these ground straps, even when you have a computer that you're setting up and you have this attached to the case, if you were to touch high voltage, there is enough of a path to go through your body, through this wrist strap, through the case and this ground to give you a very good shock. I've actually felt it before and it's not very pleasant. Not likely to kill you, but it can hurt. And if you do it the wrong way and the conditions are right, you can hurt yourself a lot. So you have to be careful doing this. It's very, very unlikely with a computer because most of the components are low voltage, 12 volts and below, and 12 volts really is not high enough to hurt you unless given like the perfect circumstances. But there is high voltage, it just doesn't get past the power supply. Now, what I'm going to do as an alternative, say you don't have the power supply in the case, but you still want to ground the case some kind of way. I'm going to use one of these guys right here. Now, ideally, you would pull these two prongs here out, the ones that are normally for your power. Now, this is U.S. power. If you're out of the country, this is U.S. power. The top two prongs are the power, and the third prong here in the middle, at the bottom, the very long one that goes in first, is the ground. So basically, what we're going to do is hook a wire to that ground and hook that wire. I got here, the other end will connect to this alligator clip, and basically what will happen is anytime we need a ground for a chassis, we plug this in, hook this clip here to the case, and it grounds the case. That way we don't have an ESD problem. Again, like I said, this can be dangerous, so yeah, if you're not comfortable with this, don't do it. It's not very difficult, but it's one of those things that if you do it the wrong way, it can definitely hurt you. If you connect to the wrong connector on this, something and then have this on connected to the chassis grounding you to it, and then you touch something else, you can definitely hurt yourself. So you have to be on point if you're going to do this setup. So I'm going to go ahead and move the camera and we'll. Okay, so what we're going to do is we're going to take this guy here and disassemble it. And as you can see, we have the three prongs that are on this side correspond to the connecting terminals on this side. So these top two here we won't use. In fact, I suggest insulating them if possible. Liquid electric tape, which is what I'll probably use. Electrical tape of some kind. Now, if you're going to use tape, use electrical tape. Don't use duct tape. Don't use scotch tape. Don't use packing tape. None of that is designed to work with electrical, and none of it protects you. If you're going to do electrical tape, do electrical tape. Now these are insulated, obviously, because otherwise this wouldn't be good for any kind of use if it wasn't. But just for extra protection, I would go ahead and insulate these some kind of way. Make sure that nothing can actually touch them. Now, what we'll do is we'll connect to the ground, this post right here, and we'll come out the other end of this and go to our alligator clip, which will make a nice chassis ground. So I just got here, I got some overkill wire. This is 14 gauge. You do not need 14 gauge for this. In fact, probably the smallest wire you could find would probably work. But the reason that I got this is because these terminals are made to take a minimum size wire, and not only that, I want the wire to have some strength so it's not trying to break itself in half if I ever happen to accidentally pull on it because I forgot that it was attached or something. So we're going to take this wire here, take our strippers, so it's 14 gauge, and I think that should be long enough. I think I'll make it just a little bit longer. I don't want too much of the wire exposed, but I don't want any of the insulation clamped down inside of the terminal either. And that looks good right there. So now this is already loose, so all I have to do is really stick it in there. And that's about as far as that screw will come out. So again, third prong, the longest one. In the US, that is the ground. It might vary if you live somewhere else. Also, you have to make sure that the outlet that you're using is properly grounded, and you also have to make sure that your house is properly wired. Otherwise, all of this is pointless. So sticking that wire in there. Well, before we do that, we need to go in this end here. I actually have something for this. So. Okay, and as a strain relief, I'm going to be using this 1/4 inch washer that'll just go up in this little end part here. It's this thing is designed to clamp down on a larger cable, but it's not going to clamp down on this wire, so there's not going to be any strain relief without something. So my idea is to stick this wire through this washer and either tie a knot or tie the wire around it, and then clamp the washer down inside of the strain relief. And that way, if something pulls on the wire, it's not going to rip it straight out of there. Okay, so what I did was I stuck the washer on the wire and tied a knot in the wire right there. And as you can see, that will not go beyond it. Again, this is a 1/4 inch washer. This is all stuff that you can pick up. I'll see if I can find some on Amazon and I'll link it in the description below. If not, you can pick this stuff up at Home Depot. Now, as you can see, I've loosened the wire strain on the plug, and I'm going to feed the wire through there. And right there inside of the wire strain, I'm going to trap the washer inside it. And go ahead and tighten these wires up, and that will be my wire strain, my strain relief. Okay, now that I got those on there, as you can see, it'll go that way, which is fine, but it is not pulling out of there. It will not pull out of there. So now that we have that taken care of, find the third prong again, and we're going to insert the wire into it. Twist the end of the wire a little bit to keep it uniform. And there's some people that say that you can put a 1 mega ohm resistor in line with this wire. Basically, the wire comes here. You have a resistor, 1 mega ohm to this, and make sure that it can never touch these other prongs at all. And basically, what that resistor does is, if for some reason you do get shorted across a high voltage power source, everything is not trying to run through your body. That resistor basically limits the current. That way you might get a nasty shock, but there's no way that it can really hurt you. With it directly wired this way, it could. Again, I'm working with computers, which is low voltage, so it's not really an issue. But if you do work on high voltage stuff, or if you work on electronics where you actually crack open the case and you're exposed to the high voltage components, then you definitely want to have 1 mega ohm resistor in line with this in series to make sure that you don't get any kind of nasty surprises. Okay, let's see. And this thing is keyed, so it only goes in one way. Make sure that our wire does not get trapped in between anything. Now, you can make these as long as you want to. This wire is 25 feet. I'm not going to leave it that long because that is far more than I would ever need. Probably 10 feet would probably be optimal. That's about what I need for it. So I'm going to measure out probably about 2 table or 2 body lengths of it and then cut it. Okay, so we have our plug. The wire is connected to the third prong. Got the strain relief washer in there so that it cannot come out. Everything is screwed down tight. Now, on wire color choice, I actually prefer green because in house wiring code or extension code, cord code, or basically any housing code in the United States, the green wire represents ground, either bare or green. In this case, you would have insulated wire, so green would be optimal. But when I went to buy this wire, they only had black in this size or red, and red can signify hot or positive depending on what it is, In housing code, black actually signifies hot, but in this particular situation, we know what it is. So now we're going to take this. Now on this other end here, we're going to go ahead and strip this wire. 14 gauge again. Now this wire is going to go on the alligator clip. This little guy has an insulator, so we're going to put the insulator on first. And now we're going to look at the clip. So some of these things you can get on with where they have screws in them. All you have to do is loosen the screw, put the wire under it or around it or whatever, and then tighten it up. Tighten the screw. But this particular one is cheap. So I actually have a better alternative. What I'm going to do on this one is I'm going to solder the wire to the clip. I'm going to use these little crimps back here to hold the wire in place to make sure that it's going to be the strain relief on this end, basically. And of course, the first thing you always want to do when you're soldering something is tin the connection. So we're going to tin the wire, and tinning basically means put solder on it. The technique you want to use is basically you want to heat the wire, not the solder. You want to heat the wire, and once the wire gets hot enough to melt the solder, it will draw the solder onto it. So there is a very thin wire, and basically the solder that's on there is going to be used to solder it to this alligator clip. And so here we have the alligator clip. Just basically have it clamped onto my wire strippers here, and I'm going to solder this . So basically what I did here was I used the crimps that were on the alligator clip to hold the wire in place. I crimped the wire right there, and then basically what I did was flooded this with solder and heated the entire alligator clip bottom, and basically that made a good solid solder connection on there. So we have good connection here. It's real strong. Not trying to go anywhere. There's a crimp in there underneath all that solder. That's bare wire from right there all the way forward. And like I said, the solder is sticking to the wire and sticking to the alligator clip. It's not a cold connection. You want to make sure it's not a cold connection. So now all we have to do in the future is when we get ready to work on something, all we have to do to ground the chassis is stick this clip on there. And again, if you have a power supply, I would use the power supply. But this is a good alternative to having the power supply. If say you're putting the motherboard, CPU, and RAM and everything in there, and you don't actually have a power supply yet, this is a good way to ground the case. Hey, if you have any questions or anything, suggestions, comments, go ahead and leave those below. Everything that I've used, I will link to below. Also, don't forget that we have an Amazon affiliate link, and I've made it easy for you to remember. There's no special funky code to remember. All you have to do is go to amazon.technoscope.com to use our affiliate link, and we get a kickback anytime you buy anything using that code. And it helps me a great deal make more of these videos. If you have any questions or comments, suggestions, or anything, go ahead and leave those below. go ahead and hit that thumbs up. I hope you've subscribed already. If you want to see more of these videos, go ahead and subscribe. Subscribing helps me a great deal as well. If you have anything to say, just let me know. I really love hearing the comments, so go ahead and leave those below. Thank you for watching. I'm Elemento, and this is Technoscope.
Technoscope is a Twisted Curve production.